Sri Gurubhyo Namaha. Humble pranams to the lotus feet of our Jagat Gurus. Good afternoon to everyone present here. Today we all have gathered here for the National Seminar on Human Space Mission organized by the Department of Physics of our Mahavidyalaya. For this auspicious occasion, today we have with us a special invitee, Dr.T.K.Sundaramurthy sir, Scientist and Mission Director from ISRO, Government of India. He is the Mission Director for Indian Communication and Meteorological Satellite Systems at ISRO. As light removes darkness from space, a prayer removes darkness from our minds. Now I request Ms. Harita of 3rd year CSC to sing the prayer song. I request everyone to stand, please.
Sri Gurubhyo Namaha. Pratasmarami lalitavadanarvindam bimbadharam pruthulamauctikashobhinasam akarnadirghanayanam manikundalaಢ್ಯಂ mandasmitam mrugamadojjwalaphaladesam प्रातर्भजामि ललिता भुजकल्पवल्लीं रत्नाङ्गुलीयलसदङ्गुलिपल्लवाढ्यां माणिक्यहेमवलयाङ्गदशोभमानां पुण्ड्रेक्षुचापकुसुमेषु सृणीर्ददानां प्रातर्नमामि ललिता चरणारविन्दं भक्तेष्टदाननिरतं भवसिन्धुपोतं पद्मासनादिसुरनायकपूजनीयं पद्माङ्कुशध्वजसुदर्शनलाञ्छनाढ्यं प्रातस्तुवे परशिवां ललितां भवानीं त्रय्यन्त्रवेद्यविभवां करुणानवद्यां विश्वस्य सृष्टिविलयस्थितहेतुभूतां विद्येश्वरीं निगमवाङ्मयसातिदूरां प्रातर्वदामि ललिते तव पुण्यनामा कामेश्वरीति कमलेति महेश्वरीति श्रीसाम्भवीति जगतां जननी परेति वाग्देवतेति वचसा त्रिपुरेश्वरीति यश्लोकपञ्चकमिदं ललिताम्बिकाया सौभाग्यदं सुललितं पठति प्रभाते तस्मै ददाति ललिता झटिति प्रसन्ना विद्यां श्रियं विमलसौख्यमनन्तकीर्तिम्.
Thank you, Harita. Sir Albert Einstein said, imagination is more important than knowledge. The space research is all apart from our imagination, and our country has initiated the Indian human spaceflight program in the year 2007 by ISRO, followed by the lunar and solar missions Chandrayaan and Aditya. Now we are going to have the Gaganyaan missions with uncrewed and crewed flights, and it is soon expected to be launched by 2024. Sir will give brief explanation about those things today, and India will soon become the 4th nation to conduct human spaceflight programs following Russia, USA and China. Now I invite the convener of this seminar, Professor Dr. K. Venkatramanan sir, Professor and Head, Department of Physics and Dean, Faculty of Science, to deliver the welcome address.
Good afternoon, one and all present here. So we have planned to organize many technical sessions, few conferences, and a series of lectures throughout this year for the benefit of students and faculty members. And as part of that, today I am very happy that students who have come to listen to the lecture to be delivered by Dr.T.K. Sundaramurthy. He is a scientist and retired mission director from ISRO. He has graciously accepted our invitation to come and deliver a talk. He gave actually two concepts. He just asked, should I speak about Chandrayaan 1, 2, 3 or should I speak about human space mission? Then we told as Chandrayaan 1, 2, 3 is out and this is an exciting topic which the world is eagerly waiting for. So sir has agreed to deliver a talk on that, and he is a part of advisory board for all these projects, and he was very successful in launching many satellites. And during the introduction about the speaker, I think Dr. Sundarajan will explain all those things. So today we are gathered here for this lecture, and on this auspicious occasion, sir, on behalf of the university and on behalf of the Faculty of Science, I wholeheartedly welcome you for coming to our university. Welcome, sir. And I would like to thank our Honorable Vice Chancellor and Registrar for granting permission to organize this event. And I would like to thank the head of CSE department and all the faculty members and students of CSE department for showing interest to listen to this wonderful talk. So with this brief note, I once again welcome the speaker and all the faculty members and students and staff for this function. Thank you.
Thank you, sir. Now may I call upon the organizing secretary of this seminar, Dr. M. Sundarajan, Assistant Professor of Physics, to introduce the guest.
Good afternoon to everyone present here. I have immense pleasure introducing our chief guest. Today's chief guest, Professor, Doctor, Satellite Scientist, Dr. T.K. Sundaramurthy sir. Our chief guest, T.K. Sundaramurthy sir, finished his graduation in Maths from Sacred Heart College, Tirupattur. Then he joined MIT Chennai and did his DMIT honors in Aeronautical Engineering. Then he went to IISc Bangalore. There he finished his ME course in Aerospace Engineering, Masters in Engineering. He joined the ISRO, Government of India, in the Satellite Center in the initial capacity as Mission Analyst. He served in ISRO Satellite Center for 4 decades, nearly 40 years, in various capacities and responsibilities. During initial period as Mission Analyst, he had contributed significantly towards the realization of India's first experimental communication aircraft, spacecraft, Aryan Passenger Payload Experiment, you may come to know as APPLE. After acquiring rich experience, he moved to Mission Development Group and served in various executive roles such as project engineer, project manager, a deputy project director, operation director, and finally, he reached the Himalayan height of mission director for Indian communication and meteorological satellite systems. He has extensively contributed in the areas of mission planning, as you are seeing now, and analysis and operations. As a mission director, he was the main architect for the design of and successful commissioning of state-of-the-art communication satellite, Eutelsat. It is a joint venture of ISRO with International Space Agency, Astrium. He also contributed for the golden contribution of HILAS, another high-end communication satellite for the UK service provider, Avanti. Our Professor TKS received a Team Excellence Award from ISRO for successful completion of WTM Eutelsat and ISRO's Advanced Meteorological Satellite INSAT 3D. And Sir was awarded a MIT Eminent Alumnus Award 2020 in the domain of space technology. Sir represented many international conferences with the ISRO. he has lot of affiliations, and all those affiliations cannot be contained in this paper. Few of you, I just tell you, he is the advisor of Sri Satyasa University of Bhopal. He is the academic council member, Savita University, Chennai. Advisory board member for VIT Bhopal in syllabus and upgradation. He is the board of trustee in SDNX Foundation. He is the principal advisor for National Youth Council of India. He is the vice president in the Institute of Aeronautics, Astronautics and Avionics. Mainly, he is the member of Planet Aerospace. It is the embodiment of ex-ISRO scientist. Overall, he is a freelancer ambassador from ISRO community, and he is usually visiting all the universities, colleges and schools, and meeting all the students and delivering the knowledge and technology behind space and missions, and he is inspiring all the minds, younger minds, and he is always in their minds. And the list is going on, and due to time restriction, we once again welcome you, sir, for our students, and they are very eager to hear your lecture. Thank you, sir.
Thank you, sir. Now, on behalf of our university, I request the convener of the seminar, Professor Dr. K. Venkatramanan, sir, to honor the guest with a shawl. Also, I request the organizing secretary of this seminar, Dr. M. Sundarajan, sir, to honor the guest with a garland. Thank you, sir. Now it is the time for what we have gathered here to listen to the chief guest's presentation. So I wholeheartedly welcome Dr. T.K. Sundaramurthy, sir, scientist and mission director, ISRO, Government of India, to give his presentation. Let's wait for a few minutes for stage arrangements, please.
again, kind of working it out to the ends.
லைட்டாக சவுண்ட் வச்சு காட்டுறேன் சார்.
சார் காட்டுறேன்.
காட்டிட்டீங்களா? ஓகே.
Hello, hello, check, hello, check.
இது ஆஃபில் இருக்குது சார், ஆன் பண்ணுவோம். ஆனில் இருக்கா ஆஃப்?
Hello.
ஓகே ஓகே, ஆனில் தான் இருக்கு. இல்லை அது சரியாக இருக்குங்களா? ஓகே இல்லையா? போருமா? ஓகே.
நெக்ஸ்ட் ஸ்லைட், ப்ரீவியஸ்
Okay,
ஸ்லைட்,
okay.
லேசர் லைட். நீங்கள் அங்கே யூஸ் பண்ணிக்கலாம் சார், ஆக்சஸ் ஆகும்.
நோ ப்ராப்ளம். இருப்பா, இது வந்து இல்லை இல்லை
வச்சுருங்க, வச்சு விட்ருங்க. ஷார்ட் பேசும்போது வந்துடும்.
என்னப்பா? வேணாம் இருங்க. இது இப்போ நம்ம வந்து முதல் ஸ்லைட்லேருந்து போயிடலாம், அப்புறமா பார்த்துக்கலாம். இன் கேஸ் எனி திங் இஃப் இட் இஸ் நாட் கம்மிங்.
கேபிள் எவ்வளோ பெருசு இருக்குது? ஆடியோ கேபிள் அவ்வளோதானே?
ஓகே சரி, ஓகே. இந்த லைட்டெல்லாம் ஆஃப் பண்ணிடுங்க. இந்த லைட் வேண்டாம். Good afternoon to all. Am I audible? Yes, sir. Okay. Before I go into the topic, okay, the topic is range problem.
One second, sir.
Okay, we'll ask. No problem. Before generally anyway, whatever I know, if I tell, that may not be very interesting. Okay, can someone tell me what is the difference between a satellite launch and a human space mission? Yeah. Someone, because I would like to know.
In a satellite, human cannot be traveled in the normal mission, sir. Here, the human can be traveled along the mission.
Why satellite human cannot fly?
Difference between these asks, that's what the reason is, sir. What is the difference between man?
No, it's not different. So, okay, fine. Okay, but why satellite I can do? My human mission is nothing but okay, it's another form of accommodating the human being in the spacecraft. That is all. Yeah, please, sir.
Manned, there are two vehicles basically in space. One is called as manned vehicle and unmanned. Satellites come under the unmanned. So manned vehicles only we can utilize for human space mission.
Okay, then what is the difference between manned and then unmanned launch vehicles?
Generally has to be launched, whereas the manned vehicle will be controlled like a car or an aeroplane.
Why even the unmanned also I will have to be controlled, because the satellite has, see whether it is a human being or a satellite, it has to reach the orbit and then I will have to use it, both I need. Other without remote control or without the guidance and control or navigation, I cannot be able to launch even a satellite or a human being. There is much more than in that. Yeah. Please.
It requires both the technology of aeroplane technology and the space technology.
Agreed. But the thing is, ultimately, we have to go to space. That is the thing. Yeah. Yes, something which is very, very significant. If I tell that, then, yes, I think somehow I don't know why we missed it. Yeah. Some of you, nothing, that is, see, unless you express yourself, you will not be able to know things. If someone wants to improve their knowledge and they wanted to know things, then they will have to question. Without questioning, we will not get the answers. Yeah. So, I presume that you don't know neither spacecraft nor human space program. Is it that way, or you don't want to come out? Unless someone tells me some answer, I will not proceed. Otherwise, I think it will be of not much use if I tell that. Yeah, I think, please come out. Otherwise, I will have to pick someone and then ask. Yeah. Okay, whatever you know, you please tell. Don't worry.
Satellite missions are not habitual for humans to go like human mission.
No,
Like
what?
human space missions, sir.
No, I am not able to get what you are trying to tell.
In human space missions, we need separate cabins for humans.
Okay, even in spacecraft also I need separate sections for the payload.
In satellite missions, we don't need, sir. Not like that.
No, that is why they do, these two things are two distinct things. From this side someone, otherwise I will pick. I am leaving the choice to you people. Okay, ma, I think, please. Hello, sir, you give the mic to her. Yeah.
Sir,
Yeah,
in human, when traveling humans, we need some oxygen.
little bit. Yeah, louder, ma.
In space, in satellites, maybe it will be in more time in space itself, sir. So may cause any health issues for humans. So it's not necessary.
Okay, you are telling health issues are the then.
Yes, sir. May.
Okay, anyway, it's all right. Okay, let me clarify myself. When I launch a spacecraft, is it a must that I will have to get it back? Say yes or no. I don't know why you people are. Fine. Now, what is the big difference? Now you can now distinguish. If I send a satellite, I need not bring it back. Whereas if I send a human being, I will have to bring him back. That's all. That is the main challenge and the main difference what you are having in the human space mission. That is why so many countries have launched the satellites so far. Why? We have launched our own. Something like, it's now touching around 500 satellites we have launched so far. In that something like 400 and odd is other countries' satellites. But we are yet to launch a human being. That itself tells you the challenges and the kind of the difficulties in realizing a space human mission. We will have to bring him back safely. That is the very big challenge. Anyway, let us see for another 30-40 minutes what are all the things involved. Okay, all these things are all okay. Our ambitions and aspirations, the service of humankind is the main thing. Okay, I can be reached in that email or okay, Professor Venkatraman KV Sari is having my number. Anyone wants some clarification on that? Yes. Or am I blocking? then I will. Okay. See, this is how our ISRO was formed. It was formed in 1960s, initiated in the INCOS Park. Then 1963, our first sounding rocket facilities were established. Then we started our space program in Saint Mary Magdalene Church in Trivandrum. This is where our space doyens like our Professor Vikram Sarabhai, our Dr. Kalam and all, they have put the roadmap for our Indian space program. And in 1966, Trivandrum, the facility was established, and then the then Prime Minister Indira Gandhi was dedicated our sounding rocket facility to UN Council. Then in 1969, ISRO was formed. In 1972, the Satellite Center in Bangalore was established. Then 1972, Space Commission was formed. Then first Space Commission Secretary was M.G.K. Menon, followed by Professor Dhawan. And we did the educational program. Actually, we started our communication program for education only. That started in Ahmedabad. Surrounding to Ahmedabad, there were some 100 plus villages have been gathered with that, and then using the American satellite ATS-6 was used, and that was our base for our communication space programs. That was done in 1975 and 76 and 79 and 77 and 79. Then of course, we have designed our own logo in 2002 that represents the rocket, that you are, whatever you are seeing, that orange is representing the rocket, and then that blue things represent the spacecraft solar panels.
There are some who question the relevance of space activities in a developing nation. If we are to play a meaningful role nationally and in the Committee of Nations, we must be second to none in the application of advanced technologies to the real problems of man and society which we find in our country.
See, I don't think any explanation is required. When our Dr. Sarabhai represented UN Council, then advanced country people, they were asking that India can afford to have a technology like space. Such kind of the well-developed nation itself, they are finding it difficult to put money in that. Are you able to have it? Further, the answer given by him I simply reproduced. Now, after 5 decades, I think, now you tell anything where space technology is not there, that you cannot. Everywhere now our arm has been spread, and now I can proudly say that yes, we have to some extent fulfilled our space father Vikram Sarabhai's thing. All our programs are meant for societal and humankind, whereas elsewhere in the world these are all being run as a commercial program. They are not being fully supported by the government, whereas in India it is fully supported by government. For the past 2 years only, okay, this government has taken a decision. Yes, I think because it is being government control, many private people are not coming out, and then the kind of expansion which we are supposed to have it is hindering. So we have opened our space industry to private people, and yes, of course, there are many people have come up. I can say currently something like 400 to 500 startups have come up in India. It's a very good thing. I hope we will see a very good future in the space technology, and we will be one among the world leaders in space technology subsequently. Then this is our organization chart. We are directly reporting to the Prime Minister and then Department of Space, and we have centers throughout India. Rather, I will not go too much into it because it takes a lot of time. Next slide, I think. This diagram shows you where all we are present. That means we are pan-India presence. So, I think Department of is the only department which is away from Delhi. We are having the headquarters in Bangalore. But our arms are spread across the India. So, for all our programs, our entire country puts into their efforts. That's why I think I am proud to say that we are successful, mainly because we are all together, all the people's efforts are being put in, and then we are succeeding in all our endeavors. This is just, I wanted to just give you an idea of how the launch vehicle programs and the satellite programs and then upcoming programs are all there. The latest addition which I can say is pointer, no, what happened? Yeah. 1 minute, pointer is, okay, sorry. See, now, apart from this regular launch vehicles, to launch the mini satellites of something like 200 to 500 kgs, we have developed a separate launch vehicle called SSLV, Small Satellite Launch Vehicles. This has the capability to launch up to 500 kg in 300 to 400 kilometers, and you know its setup time and launch, within a week we can assemble the rocket and then launch it anywhere in India. So, that does not require a special setup like what we are having in Sriharikota or the second launch pad which is coming in Visakhapatnam. Okay? Of course, then there is a question which will be, naturally when any new program starts, we will have a thing, what is the need aspect? Why a human space mission is required? I think first we have to understand, it is not that just Russia has sent it or USA has sent it or other country has sent it, I am going to send it. No, our ISRO philosophy is like this. We will analyze and see, is it really required for us? Is it going to give us something useful for our society and our humankind? Any benefit are going to be there, then only we will venture into it. That is how we, after our satellites technology, we ventured first into moon mission, that was in 2008. Then after that we ventured into Mars. Then moon, we have landed our one of the probe very recently. Then another satellite which is going to study sun, which is at Aditya, which is going to be sit around more than 10 million miles away from it, and it will be in the equal gravity pull of sun as well as earth, so that the satellite will be stable at that point and it will be keep seeing the sun and sending the data to earth 24/7, and we will be able to know more about the sun corona and all those aspects. Okay? So, like that, let us see what is the need aspect. Space exploration. Space exploration is the use of astronomy and space technology to explore our outer space, because we should know where we are living and what are all there surrounding us, Study of space is carried out mainly by astronomers with the telescopes. Its physical exploration, though, is conducted both by unmanned robotic space probes and human space flight. Observation of objects in space, known as astronomy, predates reliable recorded history. That is, I think we are, if you really see, it started something like 3000 to 4000 years back, if you start looking back the history. Development of large and relatively efficient rockets during mid-20th century allowed us the physical space exploration. Until then, it was only on observations and then by seeing through the telescopes and all. Then mid-20th century only we started having our rockets, and then our space exploration has become in reality. Then exploring space includes advancing scientific research, then of course countries' prestige, uniting different nations, ensuring the future survival of humanity, because the way in which the growth is happening on the planet Earth, it may not, a day may be there where you will not be able to survive on the earth because of the resources constraint and all other things. So, you have to look for somewhere. So, if that is the case, at that time anyway you will not be able to start thinking and then start doing it. So, we are starting that from now onwards. So, that is how that survival of humanity, then developing military and strategic advantages against other countries is mainly to protect yourself. Then benefits of space exploration, if you look at it, it helps us answer the profound question about our own origin, evolution and existence. Continuous high on the outer space provide the protection from potential impact. Then often we need new technologies for further expansion and leads to great inventions and advancements. Space exploration inspires us to look for the unknown and satisfies our curiosity. That is the main thing. It promotes international peace and collaboration. Then extraterrestrial colonization is the ultimate backup. This is what we are all looking for. Then space mining is the real gold treasure. That is whatever so called that asteroids. After all, asteroids also again it is a part of from sun whatever it has come. So, still we do not know what kind of mineral potential which they have. After maybe decades, very recently only from asteroid, a sample have been brought to Earth and now it is under the analyzation from USA. Let us hope that we will be getting some positive good results out of that. Of course, for everything anyway straight away things will not start with the thing, So, generally we start with animals for anything, even for any medical the inventions and the testing and all, we use guinea pigs and all kinds of things. Straight away it will not be given to human beings. The best example what we have seen in our period is corona vaccine. That is, I think no one will forget how that was fast tracked and then it was tested. In fact, even world community even today they do not agree that we have done enough testing on non-human beings for its effectiveness and its after effects and all. But whatever it is, to some extent yes, we have contained our corona with our own invention. I think that is a very great thing. In fact, now those people are all telling the after effects of that Pfizer vaccinations are very dangerous. I think 90% of the people who had that injection, they are having some side effects. It has been recorded now. I think 2 weeks back or so, I just saw an article and then I gone through that. Then it was really unfortunate, the people who have taken that vaccine, and I hope and pray, I think they should be having a very good health. That kind of a thing. So towards that, first we have sent a monkey. That was in 1948. It was done by Russian people. But before in the rocket gets launched itself, due to the shock, it has died. The second one which was gone is 1949, but it has reached 134 kilometer. But while coming down, due to the impact load, that monkey also got lost its life. Then of course, I think this is with that history has been made. Someone can tell me who was the first man who went to space? Neil Armstrong. Then Aldrin. I think, have you heard my question properly? Who was the first man gone to space? Neil Armstrong, where he went? Moon. My question was, that was happened in 1969. Neil Armstrong landed on the moon on 1969, whereas first human being. Okay, this was the first satellite which was launched in 57. This is the first dog which was sent to space. It was in 1961. Yuri Gagarin was the first fellow who went into space. It has happened in 1961. He was there in the orbit for 1 hour 48 minutes. Okay? He was the first fellow to be in space. It was mainly to demonstrate the advanced space program of Soviet Union, and that has opened up the human space program in the subsequent years. Of course, this is the Vostok was a launch vehicle. Yuri Gagarin was the person who went to the space first. Then Alan Shepard was the first American who went to space for the Mercury mission. That has happened in May 1961, because in olden days the race was between Russia and USA, because all other countries were not having that much rich enough to spend money for all these explorations. Okay? Then, of course, Neil Armstrong has landed on the moon in, of course, that's a history. In 1969, of course, he has landed on the moon. Then our man, Rakesh Sharma, went into space in 1984, again with help of Russia. So he was there in the orbit for 7 days and 21 hours and 40 minutes. Okay? But of course, it was an exercise carried out with the cooperation of Russia and our Indira Gandhi's effort. So she wanted to have one of our Indian to be in space. Russia was readily agreeing, and then that's how Rakesh Sharma was the wing commander. And then generally, if you look at it, all the astronauts are all fighter plane pilots. Can someone tell why? What is the reason? Why be for an astronaut you should be a fighter pilot trained person? One good reason.
Not to maintain any gravitational pull or attract something like that.
Gravitational pull, everywhere it is there, you know. Why, even if I go in aircraft also, you have the gravity pull. See, okay. See, what is happening, you know, for a fighter aircraft, they experience more Gs and they experience more speed, something like M3, M4. Like 4 times the sound of speed. That is the kind of thing. Similarly, he will be experiencing like 3 to 4 G earth gravity pull. At the same time, he will be in a weightless condition also. So that's why. But all the pilots are being trained, especially for the fighter planes. It should have a highly maneuverable things, because he should bomb and then next second he should revert back. So his maneuver should be very fast and swift. So his body conditions to be withheld all those things. So that's how they are been. Of course, for our space mission also already 4 people have undergone the training in Russia, and still now they are been undergoing the training until we have our mission. Then China's first man, that was done, that was happened in October 15, 2003. Just this, I just wanted to give you an idea. Then we should know what are all the effects of flying in the space for a period of time, what will happen to the human body. Okay? Venturing into the environment of space can have negative effects on human body. Significant adverse effect of long term weightlessness. That is the problem, because once you go to space, you don't have the weight, because there is no gravity. So you will be feeling that, then that results in the muscular atrophy and then deterioration of skeleton, because our body, because of the gravity pull, we are able to stand firmly, but if you just leave it, if that force is not there, you can be collapsible, all those things you can have. Okay, that is the main thing. Other significant effects include slowing of cardiovascular system functions, decreased production of red cells, balance disorders, eyesight disorders, and changes in the immune system. All these things are play a negative role in the human body. Then additionally, fluid redistribution, loss of body mass, nasal congestion, sleep disturbances, and then X flatulence. These are all the other side effects which you are going to have being in space. And this will be worst if your stay period is prolonged. Next, many of the environmental conditions are taken care of by having a space suit to shield the people from the harshest conditions. Like when you are flying in an aircraft, okay, if you are not having the pressurized cabins, like your pressure is maintained, temperature is maintained, or humidity is maintained, otherwise you will not be able to even breathe at that altitude of 45,000 feet. So that is how it is being controlled, the aircraft. But here that much are not there. A suit has been made to have all these conditions as if he is on the ground. Breathable air, drinkable waters, the temperature and pressures within the acceptable limits, along with the body waste management, are taken care by the life support systems. I will throw some light on all those things. Some hazards are difficult to mitigate, such as weightlessness. Nothing you can do. You have to undergo that. There is no other go. But you are being practiced to accept the situation, and how do you overcome that kind of things. Okay, I will show you one small video clip little later. Then living in this type of environment impacts the body in three important ways. That is loss of perception, then changes in fluid distribution. That's mainly because of this blood circulation itself is affected, because there is no force which is making the blood to circulate. You have to make yourself active and then make it to happen. Then deterioration of musculoskeletal systems. This is another that is your structure will be get lost. That is, you will not have that your structure, skeleton posture itself will be getting modified. Then hazards of human space flights. There are 5. One is space radiation. Now because of our atmospheric presence, all the UV radiations and all things are being filtered by that atmosphere, and you are being protected by that, whereas in the space environment that is not there. So you are exposed to that hazardous space radiation. It's not stealthy, but considered one of the most menacing of the 5 hazards what we are seeing. The topmost hazard is radiation. Earth natural protection, radiation exposure increases cancer risk, damages the central nervous system, can alter cognitive function, reduce motor function, and prompt behavioral changes. That is, it makes your normal human behaviors to little bit different. You may be behaving something different. That's why the astronauts, as soon as he come to the ground, he will be isolated for a minimum of 6 months. He will not be allowed to move with the common public. Even his family members also has to converse him with a closed cabin only. That is mainly to acquaint himself and then make him to be brought his conditions to his old to live on the earth. Then the space station sits just within Earth's protective magnetic field, so our astronauts are exposed to 10 times higher than the radiation magnetic effects are much, much more, because it is having 10 times more than what we are having on the earth. Then to mitigate this hazard, this space vehicle will have a significant protective shielding, and then it gives you a good amount of alarms, and then disarmatory and all, they will be taken care and they are being protected. The second biggest problem is isolation, because here we are all sitting with our friends and colleagues, or if you go home, our father, mother is there, or our wife and children are there, so that you can move with them. But whereas in space, you are in a confined space, you are alone. So that itself will make you some sort of a problem for you, because you have nobody to communicate, or nobody to talk, or nobody to converse, that kind of a thing. Only way is, yes, you can speak through video conferencing you can make, but how long you can have? Can we have it 24/7 video conferencing? Not possible. Maybe, but rest of the time he has to be like that. So that's what, in essence, the luxury of interacting and communications you will not be able to have. Then sleep loss, work overload, because you have to do so much of work in the space station to take care of so many other systems. You are not loaded like a normal human being, you are being loaded with so many other things which normal human beings are not exposed to. So that gives him a kind of over performance is required for him. Then adverse health outcomes, we know stress, how it can affect one's health. No? It is similar to that. Compromised mission objectives, because to meet the mission objectives, he has to sacrifice so many things of his life. To address this hazard, methods for monitoring behavioral health and adopting the, as well as the technologies which are being developed, and it is keep going on a continuous basis to detect and treat the early risk factors. That is how we are also trying to keep monitoring and try to find out new things. How do we protect him in all these risky environments? How do we take care of him to be normal as if he is in his on the earth? You know? So, and it is a continuing process, because it's only coming out of learning. Whatever the mistakes or whatever the problems which he is facing, yes, we will try to find out how that can be mitigated. That it's a continuous process we are doing. Then the third one is, it's away from the earth. It is not like, okay, now I am here. Suddenly if I get some problem now, immediately I can be attended medically. Okay, in another few kilometers I will be having an hospital. Whereas from space, 300 kilometers away from the thing, how I cannot bring him back suddenly if he gets into a problem. So that is that distance from earth is another big hazard. The third and perhaps the most apparent hazard is quite simply the distance. In case of a medical event, emergency happens, that's where we are so careful in selecting the astronaut candidate to be I can tell, if I find a perfect man, that is most ideal, but it is not possible. But that is how you can still find out, because 1 in 10,000 or 1 in lakh or 1 in 10 lakh, like that you can find a fellow. That is how that astronaut numbers are. After having in 61 it started till now, you are having only a handful of astronauts, not in thousands. The number is not even hundreds. So it is only in tens, multiplication of tens only. That is mainly because of these kind of things. He should have the quality. First of all, I can tell you, he should have all the 32 teeth intact, otherwise he is not selected. First thing they do the test is whether all your teeth are intact. Next is your eyesight. Like that, there are criteria. I think that itself I can take 3 days class. I have, in fact, when I was a committee member for when we have planned to send our one of the scientists in the space shuttle, but because of Kalpana Chawla's death, USA itself has abandoned that program, so our program also got stopped. So that way, that is how. Then planning and self-sufficiency are essential keys to successful mission. Astronaut must be capable of confronting an array of situations without support from their fellow team on Earth. That means he should know how to keep himself to undergo the problem and then how to come out of the problem. So that's how that 2 to 3 years of training given to him on the Earth, it makes him to at least he can make an attempt and then come out of the problem. Then the fourth one is gravity fields. Of course, we will not be knowing the real usefulness of the gravity. Once you go to space, then only you will come to know the advantages of being the gravity. The variance of gravity that astronauts will encounter is the fourth results, and mainly that results in the weightlessness. When he returns, he has to readopt so many things, because when he was there in the space station, he has no gravity. So to stand or to move or to even to drink, he has to do some manipulations. I will show you one video so that you will appreciate better after seeing that video. Then research being conducted to ensure that astronauts stay healthy before, during and after their mission. See, this is the main, that is, of all the challenges what we are facing, this is the major challenge what I can say is the most difficult one to fulfill, but to some extent, yes, that is being done. Then astrophoresis treatment and optimal timing for such therapies could be employed to mitigate that risk. Then research is an ongoing thing to characterize all these things, and then it again depends on individual astronauts. One problem could be created by something else, but the same need not be applicable to the other astronaut. It will be something different. Like what I can say, yes, based on my experience in the spacecraft operations, I never seen two problems repeating in two different spacecrafts. So almost 30-35 spacecrafts I have handled in my service. Not even a single satellite the problem has recurred. Every satellite gives me a challenging one, a different one. So that is how it is, a individualistic one. So that is the thing. Then of course 5, closed environments. That is, now I am standing in this big hall, whereas in space station I cannot have this big. I will be having only 3 by 4 meter. That's all. That is the area. So you have to live in the restricted environment and enclosure. That gives you another problem for you. It's a psychological problem created for you. That is, and also next thing is that temperature, pressure and the lighting conditions, quantity of space, all these things are all play a major role in that. Then technology, as often is the case, without of this world exploration comes to the rescue in creating the habitable home in the harsh environment. Then everything is monitored from air quality to microbial inhabitants. The occupants are also asked to provide the feedback about their living environment on a continuous basis. That is, they have been asked to give their conditions almost on hourly basis also, sometimes if they give some problems and it is experienced. Otherwise, they will be told you inform once in 3 hours or once in 6 hours, like that, so that we will be getting the feedback from them. Then extensive recycling of resources is more important, because I cannot keep on carrying the things for them from the ground to there. So whatever is available there, he has to reuse it. Okay, for your information, we will not even waste their urination itself. That urine is been refined and it will be used for drinking as well as producing the electricity by having oxygen and hydrogen, and we will get two products. We will get electricity and then we will get water. So this is how it is. Even human waste is not been thrown. There also it is recycled and it is used for the carbon the values, and then only ultimately only the wastes are being thrown. Okay. Of course, living in the space station, let me see whether I will be able to succeed in that video. You just, I will come. Sir KV, can you go? No, no, the time, are you allowing me? Wait, yeah. Yeah, no problem. If it is coming.
Again, kind of working it out to the ends.
Why that is not coming? Please. Somebody can give me water. Sir, water is there? Okay. No, you just find out. Oh, you want to play that? Living in space station, அதில் ஒரு வீடியோ இருக்கு பாருங்களேன். Otherwise you play independently. Oh, thank you so much, sir. ரொம்ப நேரம் இருக்குதுன்னா வேணாம். இல்லை அதுலேருந்து வீடியோவை தனியாக ப்ளே பண்ணிடுங்க. If it takes a lot of time, leave it. என்னாச்சு? Otherwise, in the end we can play otherwise. Okay, you go back to the slides, because don't waste our time, because the time is don't worry, I will take care. Yeah, I think because I thought it would be better to show that how people are living in space. Okay, due to the some presentation problem, I am not able to get the video. Okay, we will try to play at the end of this. Sir, shall I go ahead? Fine, no problem. No, what you can do, no, you stop this PPT, play only the video otherwise.
And rub it in. Again, kind of working it out to the
Good.
ends.
Yeah, nice. Give a little bit amount of volume. That is how they are living in the space station. One small clip of some 4 minutes.
In there and just kind of work it. Because without standing under running water, you kind of need to use the towel a little bit to help get some of the dirt out.
And that's it. Thank you.
It's a great sleeping bag.
So he is trying to sleep.
What's really cool about it, we can zip it up. And then we have little armholes.
What's on the menu tonight?
Strawberry shortcake. We
Oh.
have these butter cookies and some strawberries with a little bit of milk on top.
And Chris, I'm going to make one for you right here. And here's your strawberry shortcake ready for you, Chris.
Oh, excellent.
Nothing happens.
Thanks for the help, Chris. That was awesome.
More? I'm going to toss this.
Sorry. Okay. இது இந்த ஒரு வீடியோட நிறுத்திடுங்க, அந்த மற்ற வீடியோ வேணாம். ஓகே. ஸோ தட் ஏன்னா மோர் இன்ஃபர்மேஷன் they will get out of this than me talking.
This works. Usually, the honey coming out pretty
You see,
well
that is
there.
how it is.
There we go.
Even no, but see, because of the gravity anyway it comes down, but where there is no gravity, so it stays there. And even if you want to either go down or come up, you have to use a force, then no other go.
Use that one time, which is a little bit scary inside of the
Those things should have a kind of a support, otherwise it will be keep floating. See, this is how they change the room, rather the laboratory working areas within the space environment. Everything needs to be tied or it should be stick upon, otherwise it will start floating.
Here comes Luca. And now let's try backwards.
I see it. Nicely stuck.
See, this is how they do the experiments, whatever they have been asked to do, and then they are trying to have the equipments and other things, how they start moving.
Okay. I would suggest that I open these. These come matched. Thanks for the honor, guys. I really appreciate that. No, I really do.
The CCE is now trying to go to the other cabin for the experiments.
Look. Kind of cold.
Sorry, that will be still keep floating only, it will not reach the place. See, this is how they do the exercise and then keep them fit to be in the space station. I think you can stop the video. We will go to the PPT. After nothing much interesting, yeah, you can stop. Stop the video. Okay. Oh, you can skip and then we can go back to our slide. You no. Okay, fine. Go to the slide projector. Yeah. Yes. Okay, I think no problem. Okay, no, I think he has somehow it's all right, no problem. Because rather than again going back, this is much fast for me. Okay. Now only actually I have come to the topic, whereas Sarah has told me another 10 minutes only. Let me see. Our Indian space program. Okay. This actually, it is not that we started in 2019. We started this much earlier. In 2000 itself we started. For anything what we need, for any program, what is the main thing which we require? Money, that is the thing. Unless government gives us the money, what we can do, we can. But still, whatever the money allocated towards our other programs, yes, we started slowly and then we initiated our human space activity way back in 2000 itself. We were studying and what is the possibilities, how do we can achieve it, for all those things. Okay, whereas in 2019 only, okay, government has given us the fund. The main benefits, if you want to see by way of Gaganyaan, because everyone will be questioning, why by going to space, what are we going to get it? So the benefits wise you can see, enhances the science and technology levels of the country, national project involving other institutions, academia and industry. It is not only ISRO is being into this space. Then improves industrial growth, because once I have a human space program, the requirements are so much, ISRO resources alone is not sufficient. We will have to get it from various already well developed industries. Then inspires the youth to take challenges in science and technology. This is one more major outcome of this project. Then technologies developed for social benefits. Then additional human resource development. Then provides way for the international collaboration and as well as the policy improvements we can have. These are all the positive impacts and benefits out of our human space program. Then the challenges when compared to our normal spacecraft or space technology wise or rocket technology wise, whatever we have, those are all the things which we have to have, like we have to have the crew module design, environmental control and life support systems, manned space vehicle simulators. It is not only man-rated vehicles as this, as ES pointed out. Yes, we have to have the simulation for the vehicles. Then redundant navigation, guidance and control systems. Then most important thing is crew training and the facilities. Then man rating launch vehicles. Then mission management with human in loop. Crew health monitoring systems. Then robust thermal protection systems. Space suit and then crew seating mechanisms, because he has to sit after all entire that 1 week or 10 days in the 3 to 4 meter cube only. Then crew escape system, that is during the launch of a satellite, if something happens to the launch vehicle may explode, or we may be exploding the launch vehicle due to the underperform or overperform on the launch vehicle. But for a human space mission, I can't do that. First, I will have to rescue the human being from the rocket, then only I can go for the rocket destruction. So that way, that crew escape system is another very big challenging one. These are all the challenging aspects for the manned mission. I think now almost we have everything we have realized, and then we have tested also some other things. Very recently, I think not even 3 months old, we have done this crew escape system for the 3rd time. Okay, first time we did it was just escape only. It has just splashed on the sea. Second one, we were monitoring and then we were trying to have the impact the certain identified area. We have last time we have recovered that also. So that is how progressively we are going into that. Then these are all the things pictorially I am explaining. That is crew escape module will be looking like this. Yeah. Similarly, space suit is something like this. Seating systems, then the parachute device. This is the module. This is a launch vehicle. This is the kind of a tracking systems what we have. This is the control center for tracking the human space programs from its launch until we recover him back to the earth. So these are all the things. Of course, these are also we have done to some extent all these things. Then You can say ambitions are okay, these are all the things which we are looking for in our space mission. That is the crew module in which 3 astronauts will live for space, and they will be accommodated in that 3.7 meter by 7 meter. This will be enabling to achieve higher levels of reliability in the launch vehicle, and of course indirectly it is giving 15,000 employments, and then among that 15, 900 will be in ISRO. Then human space flight will take 16 minutes only to reach the orbit, and they will stay for, okay, that the duration is yet to be, it could be 3 days, 5 days or 7 days. Then the spacecraft will be placed around 300 to 400 kilometer altitude. Space Agency display the Gaganyaan crew module and space suits in the Bangalore Space 6th edition. Last year it was done in Bangalore in that what is that, we have our auditorium. Then space suits were developed from Vikram Sarabhai. Then with the ability to hold one oxygen cylinder, the suit will allow astronaut to breathe for 60 minutes. Then the capsule will rotate around the earth once in 90 minutes, and then they go around the earth almost 16 times a day. Of course, it takes 36 hours to land on the Arabian Sea, from where it starts descending. Of course, the project cost is approximately, today it is around 14,000 crores. ISRO will receive assistance from other countries also. In that, France, Russia, USA is also now ready to help us in the technology developments. Of course, the benefits what we are going to get is progress towards a sustained and affordable human robo system, advanced technology capability for understanding the human space exploration, future capability to actively collaborate in the global space station development, create a broad framework for either academia industry partnership, then ample scope for employment generation, and then our HRD development, unique opportunity to inspire youth in science and technology that encourages knowledge, innovation and creativity. Of course, having a vibrant human space program to strengthen our international partnership. Already world space faring countries are looking upon us for the help. Once we were looking upon them to have our satellites to be launched, now the condition is reversed. USA is waiting for us to launch their satellite, that is our NISAR, that is that radar, synthetic aperture radar satellite, which is undergoing the testing. Probably first quarter of next year or second half, that satellite will be launched. So this is a brief mission profile of the our space mission program. See, if you really see the this is where launch will be taking place. This is how it will be injected into the orbit. Then after spending that 3 days or 4 days, that is after that, then the descent will start from here, and it lands in the near to coast of Gujarat coastal. It will be returning. That is what you are seeing here. So this is how that the mission profile is. But this whole things, this is taking 16 minutes, whereas this takes care around 35 minutes or so. See, this is how that service module, crew escape module, and then the crew module is looking like. Here only I think battery power is not sufficient. That whatever you are seeing, that is the crew module, where you are seeing the crew is getting set. The service module is that is the crew escape module. If we get into a problem in some of the launch vehicle, then first thing is that fellow will separate along with the crew. Then we will, this is how that ascent and descent is going to take place. That is the kind of a change what we are going to do from our launch vehicle GSLV Mark III. We are using it to launch our communication satellites. That is how that top portion is going to be modified. That modified version you are seeing on the right side. Then this is how that transformation is going to take place. This is the crew module, this is the service module, that is the assembled one, and that is where it is integrated to the launch vehicle. See, this is how that space suit is looking like. See, if you see, each part of the suit is designed to take care of some part of the activities. I don't want to explain, but you can see that each one it is being designed for some specific purpose, and also it will do the job of what your aircraft, when you are sitting, all the environment control is being done. Similar to that, here also it is being taken care. Just I wanted to show you how complicated to realize this and how it has to be used. Then the exhibition what we have conducted last year, some photos I just wanted to show you people. For the launch vehicles, launch site, we have made a lot of changes to accommodate the human space flight. What are all those things? Anyway, I will not going to explain, but that gives you the kind of a bird's eye view of where all we need the changes, and then we have done all these things. Now it is fully ready to have the launch. Towards realizing this, we have launched a capsule in 2007 itself, and then we recovered it back after 12 days. That itself was a very good demonstration of bringing the human from space, but without human being there, we have brought it down. Okay? So this itself will show you an idea that we have not started our human space program in 2019. We started in 2000 itself, and then the work was going in a snail phase. That's the only difference. Now it going in a full-fledged way. This is where our crew module was recovered, and that test was done. Okay, here I will not go for the video. This again that, okay, what is our boost phase, deboost phase. Okay, this training also will take times, I don't want to do it. See, this is how our capabilities. We are having our space transportation system, we have our satellite systems, then applications also we are very clear. Regarding to take care of the human life support systems, yes, we have already built in. Then astronaut training center and facilities, part is already been established in our new Bangalore near International Airport in Devanhalli. That is around 20,000 square foot we have already established, and then the training facilities are going on. Then human launch vehicle is already ready. Then this is a kind of a continuing activity, that is we are going to do crew selection, base training, advanced training, then specific training to handle certain situations, then crew readiness also. We have all these things we have completed, we are fully ready to launch the mission. Then perspective, if you see, it's not that first we simply send a human being and we will stop with that. No, it is not. We will try to go, and then from 3 days it will be extended to 7 days. Then we may have a long duration stay. Then we will have a docking, that is 2 space modules will be joined together, and then we will have a kind of a space station kind of a thing, and then assembly we will try to have, and then technology for interplanetary missions, then colonization of moon, Mars, all these things are in the pipeline. Okay, in the long run, I don't know whether, when, I cannot say that. The international collaboration wise, if you look at it, crew training, life support system and flight suit, these are all we are getting it from foreign people, as well as we have our own human rated vehicle, orbital module, launch pad system and certifications. Then these are all the experiments which we are throwing it open to the international forum to come and support us, as well as they also can get. See, this is our that astronaut training facility what we have established. You see here that control room. Here you see the crew module sitting arrangements. That is the telemetry tracking system kind of a things. Then of course this also I will skip. The schedule wise, if you really see, first test mission which has already happened, that is the 2 months back we had the launch. Second one is yet to take place, maybe this year end or January it will happen. Then first uncrewed launch, it will be taking place in the second quarter of 2024. Then second series of test missions, that is D3, D4 as well as second uncrewed mission will happen sometime in the later 2024. Then with one robo we will be having one more. So after successful of 3 missions, we are targeting to have the space mission in 2024 if everything goes well. Otherwise by 2025 an Indian should be in space. That is what we are all praying for and then working for. Then of course for everyone there is a vision. For us also operational services continuation, enhancing the imaging capability and weather prediction, space science missions to better understanding the solar system and universe, development of heavy lift launcher, lunar and interplanetary exploratory missions, reusable launch vehicles like what Elon Musk is doing, human space flight.
Indian space, future vision. Benefit every citizen, role in literacy and mass education, create vibrant space industry, significant global space presence, expanding the spirit of exploration, space environment for industrial and scientific activities, leapfrog to frontiers of high technology.
Yeah, this is the vision. This also you skip because for want of time. Sky is not the limit for us. Nothing is impossible with hard work. Similarly, nothing is possible without hard work. We are better among the best. Thank you very much for your patient listening. Okay, we can spend some time if some question answers are there.
Dear participants, the session is open for discussion. You can ask your queries with sir. Any clarifications? No need to hesitate. Sir will try to answer.
விட்டா போறோம்னு உட்கார்ந்திருக்காங்களான்னு தெரியல.
Any clarifications, questions? Whatever doubts
I
comes
think,
to your mind, you
am I
can
right?
clarify.
When Professor K.V. sir is telling yes, all can go, we are all expecting that moment, including me, because I am tired.
Most of them are Telugu students are here.
Is it? Oh, okay, okay. Yeah, please. Any questions? I think there are in that case only 2 things. Either you have not understood anything or you have understood fully. But second version cannot be. So first one is only applicable. Yeah. Some murmuring I am hearing. If my hearing power is not bad.
Thank you, sir, for your thought-provoking presentation. It was really an eye-opening and inspirational speech for the students and those who are interested in the field of space science. Thank you once again, sir. We have a we have understood the things, including starting from basics, what is a spacecraft, and what are all the merits, what are all the demerits, what one will face as a hazardness when enter into space. So nook and corner, almost whatever basics one has to know, we have understood only because of you. Thank you so much, sir. Your ideas. Thank you, sir. Now let me invite Dr. J. Suganti ma'am, Assistant Professor of Physics, to propose the vote of thanks.
Good evening, one and all present here. On behalf of Department of Physics, I convey my hearty thanks to our Honorable Vice Chancellor Professor Dr. Srinivasu for giving permission to the national seminar. I am also very much thankful to Registrar Professor Dr. Sriram for his encouragement and support, and Professor Dr. Venkatramanan, HOD of Physics, Dean Science, his wonderful motivation and guidance that radiated a source of energy within us. We take this golden opportunity to thank the respected chief guest of this function, Dr. T.K. Sundaramurthy sir, Mission Director, ISRO Government of India, for giving his excellent talk on space technology and human space mission. We felt entered to the space, sir. I extend my sincere thanks to Mrs. Bharati ma'am being with us. I extend my heartfelt gratitude to each one of you for making this event a memorable success. Your presence and support have been truly inspiring us. And a special thanks to our dedicated team members who supported successful coordination of this program. Thank you, sir. Thank you all.
We have come to the end of the session. Let us all stand for national anthem. जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल वंगा विंध्य हिमाचल यमुना गंगा उच्चल जलसि तरंगा तव शुभ नामे जाहे दव शुभ आशीष माहे दाहे दव जय गादा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद. Thank you, participants. The tea is arranged outside the auditorium. Kindly have it and you can leave. Thank you.